So, dear all, in this class we will discuss about what is a digital multimeter. So, probably this topic is associated with first year students, those who are studying the basics of electrical and electronic engineering, in which they will be studying some measuring instruments. So the course like measurements and instrumentations will be having these kind of topics, these kind of units. So in such things we'll be having a new few measurement uh, devices like a voltmeter, ammeter, energy meter, so digital multimeter, then megger kind of instruments, then some oscilloscopes like CRO, DSO, then spectrum analyzer. So such kind of things will coming under um, uh, this measuring instrument. So in which let's start with a digital multimeter. So this device is used in our day-to-day life, that is a technician's or electrician's life at everywhere. So wherever you want to work with electrical connections, so we have to analyze the circuitry. So for that purpose, for the measurement of voltage, current, and resistance or continuity, so these digital multimeters are very important. So and also it is a very common and important laboratory instrument. So each and every laboratory, so will be having this digital multimeter. So it will be having three different operations in one device. One is we can able to measure the voltages either AC or DC. We can able to measure them. The second, we can able to measure the associated AC and DC current. Then third one, we can also able to measure the parameter like resistances. So these all things are displayed by means of a digital display. Then so since it is a digital output, yeah, we can able to get very accurate readings. So that is one of the advantage of a digital multimeter. So the accuracy very high. Then also we can say the digital multimeter, as per the name suggested, so it can be used for different measurements with different or multiple circuit characteristics. So we can able to measure multiple characteristics of a circuit like voltage, current, and resistances. Then these are the main parts of a digital multimeter. It has a display, it has a selection knob, then it has ports. So this is a general diagram of a digital multimeter. So in which the main port is a LCD display, so which is laying on top of this that is multimeter. So it is a usually it is a 4-digit supply. It's 4-digit display. So below that we will be having the selection knob. So in the upper circle of the selection knob we'll be having measurements for DC voltage as well as AC voltage. In the lower circle of the selection knob will be having the will be having the measurements for resistance in the left side, and in the right side will be having some DC current kind of measurements can be done. So okay, also we'll be having a number of ports in the bottom of the digital multimeter. So the black one representing the common or negative connections. Then we'll be having two red port. So the a red port which is with 20 milliamps is not usually connected. So it will be connected when only when high currents to be measured. So, okay, otherwise we'll be having the second, that is a top port for making connections. So also we'll be having the continuity test. We can able to perform that. So continuity is nothing but if you want to check the continuity of a circuit, that is whether it has any wrong connection of wires or it has any open circuits in the middle, if to ensure the flow of current through the path. So we are testing the continuity test. That also can be done by means of this digital multimeter. Then these are the common symbols which we are using in digital multimeter. So it is a AC voltage, DC voltage, the heads, positive, negative, ohms, then symbol for diode, then continuity of audible continuity, ground capacitor, microfarad. So then micro, milli, mega, kilo kind of value representations, then overloading, OL representing the overloading. So these are the common symbols which we are using in digital multimeter. Then first let's see what is a ports. So there are two ports which are connected to two probes. So we are connecting them to across any circuit for the particular measurement. So where the COM stands for a common port, so which is always connected to the ground. Then next, as I told you, we have two different red color port. So one port is for measuring the current greater than 200 milliamps, that is nothing but 10 amps port. Then another the regular port, which is nothing but milliamps voltage ohm. So that is a port. So this port will be used to measure the current which is up to 200 milliamps. So that is a port which is usually connected. So this is the inner view of a piece of a multimeter. So it has a simple PCB circuit inside of it. So where we are connecting number of resistors, capacitors, then buzzer kind of circuits, and PTC, that is positive temperature coefficient, the thermistors. Then we have the buzzer here. Then we have the crystal displays here for accuracy. So then battery for supplying the energy to the digital multimeter. So likewise we'll be having n number of devices which are connected in the back end of the multimeter by means of the PCB. So the PCB has two sides. One side we are connecting the LCD display, then selection knob and port connections, which we are facing the which is nothing but front end of the multimeter. So which is nothing but top side of the multimeter. So in the bottom side, so in the back side of PCB, we will be having all the circuit connections along with various components which are getting connected for circuit and operations. So these are the few set of components that are connected in the PCB assembly. So they are nothing but resistors, capacitors, diodes, and few ICs. Also we have something called a battery, crystal oscillator, then PTC thermistor, LCD, and the buzzer. So usually buzzer is used to test the continuity of a device. If the continuity is not happening, it will be ringing. If the continuity is there, so we will be getting the accurate results. Then this is how the working of a knob used in the PC, that is a knob used in the multimeter. So as I told you, the PCB is connected with the top casing of the multimeter. So with the help of screws, then we have the LCD display and rotary knob switch in the top side of the PCB as well as in the multimeter. Also we can have the on and off connections in the front side, in the top of it. Then in some cases we'll be having the rotary kind of switches for making the multimeter on and off. Okay, then various selection knobs available in the multimeter. They are used for selecting the appropriate milliamps of current or voltage and resistance values. Then here we have a display. So it is a LCD display. It is embedded over the PCB. So it is connected through the pinouts. Then it has some plastic casing for avoiding scratches. Then it also having some shock absorption mechanism, like having the upper pads. They are associated with the top and actually top and bottom of the LCD. So usually this LCD display can able to display 4 digits. So also it can able to display some negative sign also. Then if you want to increase the intensity, in a few multimeters have the illumination setup also, so that we can able to make a high intensity light during the low light situations. So this is a general block diagram of multimeter. So here we have the constant current source. So this block particularly used when resistance values to be measured. So this constant current source will be delivering some constant values or fixed values of current across the circuit. Then there will be some voltage across the circuit will be happening due to this constant current. So by having the Ohm's law, R is equal to V by I, by making the values of V and I into this I into that equation, we can able to measure the resistance value. Also we have the buffer amplifier to avoid the overloading effect. Then we will be having some calibrated attenuator for suppressing the unwanted signals. Then we have current to voltage converter for converting currents into voltages. Then also here we have a rectifier circuit. As we know, the rectifier used for converting AC into DC. That is the purpose of rectifier circuit used in this. And then analog to digital converter we have used. So since we know that all the measurements are in analog, that is electrical signals, they should be converted into digital display for or digital kind of things for the display. So we are employing some ADC converter here. So that will be converting analog signals into digital signals for the display. So this is a switch kind of thing, that is knob switch, which is a selection switch used for measuring the voltages. So as I told you, the star black color V star representing the DC voltage measurement, then red color V star representing the AC voltage measurements. Then the 20 star setting used for measuring the voltage beyond 20 voltage range. Then usually if you want to measure any kind of voltages, so you have to set the knob which is greater than the value to be measured. So that is the first thing. So if you want to measure 20 voltage range, then you have to keep the knob more than 20 volt. Then this is a function used for measuring the voltage and that is current and resistances. So it is employed in the lower part. So where ohm setting with star connection used for measuring the resistance. And then the A with star representation used for measuring the DC currents. So this is a way of measuring the resistances. If you want to measure, that is, if you want to measure the value of any resistance, you have to keep the selection knob above the value, greater the value of that resistance to be measured. For example, if you want to measure 5000 ohms resistance, you have to keep the set dial to 20 kilo ohms, that is 20,000 ohms, so that we can able to get accurate reading of the resistance. Otherwise, it will display the number one in the display. So if the selection knob is not appropriate for displaying the output, it will be showing it as one here. So here, so we can assume that so there is a problem with the display. So there's a problem with the selection knobs, and we have to make the arrangement accordingly. So these are the few advantages of a digital multimeter. So they'll be having a very high accuracy. So they'll be having the very high input impedance, so that we can able to avoid loading effect. The numerical display also used for avoiding the zero parallax error. Then these are few disadvantages. So if there is any frequent measurements of fluctuations, frequent measurement fluctuations, it can't able to work well. Then when compared to the analog tape, these kind of digital things are very expensive due to LCD display. And then it is very difficult to find the one for the specific needs. So these are the few disadvantages of a digital multi